This is the second half of lesson 7.4. In this lesson, we will learn how to use the change of base formula to calculate logarithms. This is the change of base formula, and what it says is if you have a log of any base for some number, you can calculate that number by using a log of some other base with the number here on top and matching base to what you choose on top for your base number on the bottom here. So the way I remember it is the tall number goes on top and the base number goes on bottom. Okay, so let me give you an example, one that we know the answer to. If we do log base 3 of 9, we know the answer is going to be 2 because 3 to the second power equals 9. Using the change of base formula, we can calculate it in a calculator by doing log of 9 divided by log of 3. Since there is an unwritten base on each of these logs, we know that that means base 10, but log base 10 is the one that your calculator will do. So log of 9 is 0.9542 and log of 3 is 0.4771. If you divide those, you get 2. So the answer is 2 here, which we did just using properties of exponents and logs that we know. Answer is here, 2, using the change of base formula. The change of base formula is especially useful when you're trying to calculate something like log base 81 of 27, because it's kind of difficult to figure out what exponent turns an 81 into a 27. So rather than try to figure out our exponent, we can just use the change of base formula, and we do log of the tall number, which is 27, divided by log of the base number, which is 81. And you should try this in your calculator, make sure you can get it to work, but it comes out to 0.75. In example C, we have log base 8 of 32. Again, it's possible to figure out this log by doing 8 to the x power equals 32 and figure out what exponent you need. It'll be a fraction, but you could do it. If you don't want to take the time to do that, you can use the change of base formula and do log of the tall number, which is 32, divided by log of the base number, which is 8. And we get 1.6 repeating, so that would be 1 2/3, which equals 5/3. So if x is 5/3, then 8 to the 5/3 equals 32. That should make sense to us because 8 to the 5/3 means the cube root of 8 to the 5th. And the cube root of 8 is 2. 2 to the 5th is 32. So we can get our answer 5/3 by kind of guessing and checking on this problem, or we can use the change of base formula and we get our answer using a calculator. In example B, this one is not, you can't even figure it out by doing 5 to the x equals 36, except by guess and check, because 5 doesn't turn into a 36 with any kind of fraction. So the only way to solve this is with change of base. So we do log of the tall number, 36, over log of the base number, 5. And we get 2.227. Make sure when you're calculating these, if it comes out to a decimal number, that you carry it out to 3 decimal places. Okay, example D, we're going to do log of 18 divided by log of 4, which is 2.085. Again, make sure you carry it out to 3 decimal places. And then, of course, we could check this answer by doing 4 to the 2.085 power should come out to 18. You can check that in your calculator. One common use of logs is the pH scale. If you've taken chemistry, you should be somewhat familiar with the pH scale. And the formula for pH is that pH is calculated by taking the negative log of the hydrogen ion concentration. So the hydrogen ion concentration for ammonia is 10 to the negative 11th, and for vinegar it's 6.3 times 10 to the negative 3rd. So if we want to know the difference in the pH levels of ammonia and vinegar, we can calculate each one separately. So the pH for ammonia is going to be the negative log of 10 to the negative 11th. This comes out to be 11. So then we can calculate the pH for vinegar. That'll be the negative log of 6.3 times 10 to the negative 3rd. And that comes out to 2.201. So the difference in pH between ammonia and vinegar is 11 minus 2.201. So the difference is 8.799, or approximately 9. And that's it for lesson 7.